Let's start. Right topic, feasibility. That means basically a spontaneity, feasibility or a spontaneity of cell or reaction and gives free energy and gives free energy. This is the topic. Now we need to know whether the cell or the reaction is feasible or not. Feasible, that means spontaneous, that means cell will work on its own or we need to add some external agent. So basically this topic is feasibility of cell and gives free energy. So here we have a formula delta G, that means change in gives free energy, is equal to minus NFE cell. Either we can write this or this delta G naught that represent a standard gives free energy. Change in a standard gives free energy will be equal to NFE naught cell. So I'm going to write where delta G naught is a standard gives free energy. A standard gives free energy. The standard gives free energy. N is number of electron transferred, lose or gained. N is number of electrons transferred. F is Faraday's constant. F is Faraday's constant. That is basically 96,500 Coulomb. And then here E naught cell. That means a standard electrode potential. A standard electrode potential. Please write it and let me know when you are done with this. Then I will give some questions to you. Let me know, Sneha, when you are done with this. Hamza, you are also done with this. So in the previous class, you have seen that how to write an equation from a representation and how we are going to write a representation for an equation for a reaction. Now, this formula we will use after a topic that is called electrode potential. This electrode potential. So write a topic that is electrode potential. So basically, what is this electrode potential? So in electrode potential, you know that there will be oxidation as well as reduction. So there is a container in which a rod is present, and this rod is metal rod, and here we have metal ions. Metal ions. So see what happens. Just say this metal has tendency to oxidize. This metal has tendency to oxidize. That means it will lose some electrons. So metal rod will lose some electrons. Just suppose it goes into oxidation state plus n. That means it loses n electrons. So basically here we are going to define potential. Okay. Wait a minute. So see, we have basically this potential. We need to calculate the potential difference and define potential difference. What is the potential difference? So basically, the potential difference between the electrode, that means metal rod. We are talking about metal rod and its ion, and its ion. That here will be ion. The potential difference between metal rod and its ions under equilibrium is called electrode potential. To be more specific, you can see there is oxidation takes place, so we can write oxidation potential. Sorry, oxidation potential. So basically, the potential difference between metal rod, electrode, and its ion, that potential difference is called electrode potential, and here oxidation takes place. That's why it is called oxidation potential. Please write it. Let me know when you are done with this. Are you done with this, Sneha? Oh, wait a minute. Under equilibrium. Okay. Now see, in this cell, there will be oxidation as well as a reduction. So see, I'm going to take another container on the right hand side, and there will be metal rod too, metal rod, and metal ions also. But here, M plus N will reduce. So basically, this metal's tendency is the tendency of metal is reduced. Basically, the tendency of metal here is reduction. That reduction will take place. Now, see how reduction will take place. Plus N state in an ion will gain an electron to convert it into M solid, neutralize it. So here, this N electrons, where it comes from? Basically, it comes from rod. From rod. Now we are going to define potential difference for this. Potential difference between electrode, that is metal, metal electrode, metal, and its ion in electrolyte, its ion in electrolyte under equilibrium is called electrode potential. Is called electrode potential. And to be more specific, this is reduction potential. This is a reduction potential because reduction takes place. So please write it also. Let me know when you are done with this. Very good. Now see, factors on which, write a topic. Wait a minute, it's not working. Factors affecting electrode potential. On which factors basically electrode potential depends. So the first factor is nature of metal and its ions. Nature of metals and its ions. So see how nature of metal on it and its science electrode potential depends. So basically, you know, zinc will be converted into Zn plus 2 electron. But there are some d block elements which can be converted in more than one oxidation state like this. So it depends upon how it is converting, how many electrons basically it is losing. You can see Fe in the first case lost 2 electrons, but in the second case lost 3 electrons. That's why this will have different electrode potential. So basically, electrode potential depends on the nature of metals and its ions. The next is concentration of ions. How much concentration you are taking? Concentration of ions. So basically M plus N. In aqueous state, we take concentration, or in case of gas, we take partial pressure. So how many partial? What is the partial pressure? The electrode potential also depends on the partial pressure if the formation of product is in gaseous state. So please write it. And the third point, which is very important, temperature. We will see in our equation how electrode potential will be dependent on temperature. Please write all these points. Thank you. Now, next is basically we need to learn about a standard condition. What is the condition for a standard? So write a standard condition. I'm going to write standard condition. So in a standard condition, the concentration, there will be some conditions like the concentration of metal ions should be 1 m. Next, if it is in gaseous state, pressure in gas, we either take 180 m or 1 bar. And the third is temperature. At a standard condition, the temperature must be 298 Kelvin or 25 degrees centigrade. So this is about a standard condition. After that, After this, I'm going to introduce a formula to calculate electrode potential. And we will use that formula for the spontaneity or feasibility of a reaction or a cell. Let me know when you are done with this. Sneha, Hamza. Very good. Now see, in this cell, there is reduction and oxidation both. You can see that there is oxidation. That means M is oxidized into M plus N. That means an electron loses. So we are going to represent it as E naught M slash M plus N. So basically you can see M is converting into M plus. In this state, solid state, elemental form, the oxidation state is 0. So you can see 0 is converting into plus N. That means this is oxidation potential. This is oxidation potential. And we denote it as OP, oxidation potential OP. And just remove this knot for this E. Now, if I'm going to write E naught M slash M plus N, you can see 0 is going into plus N. That means this is a standard oxidation potential, a standard oxidation potential. Not is used for a standard condition, SOP. This is called SOP. In the same way, I'm going to write for reduction. I'm going to write for reduction. Reduction, that means gain of electron, and you know that M plus N will gain an electron to convert it into elemental form M solid, which has an oxidation state 0. So here you can see plus N to 0, reduction takes place. So I'm going to write E plus N slash M. So you can see from plus N to 0, this is reduction potential. This is a reduction potential. And if I'm going to write E naught M plus N slash N, this is called a standard reduction potential. This is called a standard reduction potential. Now, one thing is to remember, which is very important. This is called RP and this is SRP. So if in the question, if it is given that calculate electrode potential or a standard electrode potential, so what we need to calculate, since oxidation potential is also electrode potential and reduction potential is also electrode potential. So IUPAC says that IUPAC says that whenever we are going to calculate electrode potential, that means we need to calculate reduction potential. So first write this, then I will explain it soon. It's very easy. Are you done with this? Very good. Now see, we have electrode potential of two types. Electrode potential is of two types, that is oxidation potential and reduction potential. Now, according to IPA, electrode potential is equal to basically reduction potential. Electrode potential is equal to reduction potential, and a standard electrode potential will be equal to a standard reduction potential. One more thing you have to remember is that the potential for gaining electron will be equal to potential for losing electron, but they are opposite in sign. That means basically oxidation potential will be equal to minus of reduction potential. So a standard oxidation potential will be equal to minus of a standard reduction potential. Always remember that. And whenever there will be question to calculate electrode potential, that I am going to define a formula here, we will take reduction potential, whether there will be oxidation or reduction. If there will be oxidation and oxidation potential is given, we need to convert that into a reduction potential by just changing the sign. Please write it. In the previous class, we saw that oxidation will take place on the left hand side at anode, reduction will take place on the right hand side, that is cathode. This is very important. Let me know when you are done with this. Very good. Now I'm going to introduce a formula for electrode potential, calculating electrode potential. Now we have two containers. On the left hand side, it is anode. This is electrode, which is connected with the electrode on the right hand side, and this is voltmeter. Now you know that this will be m plus n, so electron will increase here and m plus n will go and reduce here. So basically this is oxidation and this is reduction. This is cathode and this is anode. So here you know that n is converting into m plus n electron, and here you already know that n plus n will gain an electron and converting into m, reduction. Now the most important thing is that we are going to derive a formula for EMF of cell. EMF of cell is equal to basically electrode potential of basically oxidation potential here plus here you know that there will be reduction potential, addition of both. This is, but you know that this is for anode because oxidation takes place at anode, and this is cathode because reduction takes place at cathode. And I told you that whenever you are going to calculate electrode potential, just change this. If it is oxidation potential, you need to change it into reduction potential. So you know that this is oxidation potential of anode, that will be equal to minus of reduction potential, minus of reduction potential. Just change the sign. So I'm going to write this will be in negative reduction potential, plus it is also reduction potential, but this is cathode, and this is for anode type. Also, we are going to just change it, the value, just going to solve it. This is positive, so I am going to take it ERP minus ERP. So basically this is for cathode and this is for anode. So this is for E cell. This is for E cell. So the formula is very easy. E cell will be equal to E right minus E left, because you know that on the right hand side there will be cathode, on the left hand side there will be anode, and both electrode potential should be a reduction potential, not oxidation potential. Or E cell can be written as E cathode minus E anode. Important thing is that you know that at anode there will be oxidation, but we need to take the value of reduction potential. So I'm going to write RP. Take RP on both sides for both of them. And E naught cell, we can write E naught cell is equal to E naught cathode minus E naught anode. This is very important. I will give some example of it, but first you are going to write it. And please let me know when you are done with this. Very good. Sneha. I'm sliding it down. Please write all this. Both should be for reduction potential. Reduction potential. This is, since this is E naught, so this is for SRP, a standard reduction potential. This value will be given. You just need to put the value and get your answer. Now see, there is a question on this. Thank you. Question is basically Ni slash Ni plus 2 double slash Ag plus, which has one M slash Ag, and there is more information given as E naught, that means the standard electrode potential of Ni plus 2 slash Ni is given as minus 0.25 volt. Again, E naught Ag plus slash Ag is given as 0.80 volt. Now we need to calculate, find E naught cell. So we have a formula, E naught cell. We need to calculate E naught cell. So I'm going to explain it. See it carefully. E naught cell will be equal to, either we are going to take E right minus E left, or we can take E cathode minus E anode. And since we are talking about naught, so take naught with it. E anode. So this right and left is for the representation, because in the representation, right side is for cathode and left side is for anode. So this is for right and left is for representation, and cathode anode, you know that on the right hand side it will be cathode and anode. Now you need to take care of it. Right should also be SRP, a standard electrode potential, a standard electrode potential. In the same way, a standard reduction potential. Now on the right hand side, you can see Ag plus is there. And what is the value here? Ag plus 0.80. So first of all, check from the representation whether the value is of oxidation potential or reduction potential. How we are going to check? Just see Ag plus, that means plus 1 oxidation is going into 0. Is it oxidation or reduction? Sneha, plus 1 oxidation state goes into 0. 0 oxidation state. Is it oxidation potential or reduction potential? Please message me in chat box. Is it oxidation potential or reduction potential? Can you answer me? No, if tell me. Na plus is going into Na, that means it gains electron. Now, Ag plus is going into Ag, that means it gains electron. And when it gains electron, it is reduction. That means the value is a standard reduction potential, which is good for us. Now, on the left hand side, you can see Ni is there. So Ni plus 2 has a value that is minus 0.25. Now, tell me whether it is reduction or oxidation. On the right hand side, the value is for reduction potential and not is given. That means a standard reduction potential. Can you tell me whether plus 2 is going into 0? That means oxidation or reduction? Hamza, Sneha, oxidation or reduction? Please answer me. Do you have any doubt in this? Please ask me. Ni plus 2 is converting into Ni. And if it is in an elemental form, that means oxidation state 0. Here the oxidation state plus 2 to 0. Whether it is oxidation or reduction. Hamza, I'm waiting for your answer. Reduction. So it's good since we need to take only the values. So E naught cell on the right hand side minus 0.80 minus what is the value on the left hand side 0.25. So if you are going to check it 0.080 plus 0.25, which will be equal to 1.05 volt. So the value of E naught cell will be equal to 1.05 volt. Now, why do we need to check? If there is value of oxidation potential, so we just need to change the sign and you will get reduction potential. Please write it. Hamza, you will receive a notification soon. You don't speak, you don't reply at all. Hamza, you don't reply at all. This is your first message I am getting. I know if your mic is not working, you can reply through chat box. You can reply in chat whether you are getting or not. I really don't get it whether you are you have any doubt or not. You just say you just reply me in the beginning of the class, then all 1.5 hours is like you have nothing to learn and anything. Sneha, are you done with this? Okay, I'm going to give you a question. Okay. Today's class will be for 1 hour only. I will take uh, tomorrow's class. I will extend in tomorrow's class. That means Zn slash Zn plus 2, 1n slash Cu plus 2, 1n slash C. Now we have basically E naught Zn plus 2 slash Zn is minus 0.76 volt, and E naught Cu plus 2 slash Cu is given as plus 0.34 volt. Calculate E naught cell. This is the question. Please calculate it. Let me know if you are unable to solve it. Manisha, any answer? 1 point. Wait a minute. Your calculation is wrong. So see how we are going to calculate E naught cell will be equal to E naught right minus E naught left. On the right hand side, Cu plus 2. This is the value. So after that, you have to check it. Plus 2 converting into 0. That means this is a standard reduction potential, which is good. Oh, wait a minute. Okay. 0.34 minus on the left hand side, this is zinc, and it is also a standard reduction potential. It is also good. So minus 0.76. When you will add it, you will get 1.1 volt. Is that clear, Hamza and Sneha? No, Hamza, not -1. How can it be -1? See, plus 2, it is plus 0.4, 0.34, and there is minus in the formula, and this is already in minus. So minus minus will be plus, na? So it will be 0.34 plus 0.76, and the answer will be plus 1.1 volt. Okay, okay. This is what I want. At least you should reply. You all should reply. Okay. So this class will be only for 1 hour today. I will take extended class for tomorrow, Sunday. There will be additional half an hour of class. Okay, Sneha and Hamza, will that be okay?